In this tutorial, I'll show you how you can perform a multiple linear regression analysis in Excel using the Data Analysis Tool Pack. The first thing is to take a look at our data. In the first column, we have the movie names. These are considered some of the best movies of the decade of 2010 to 2020. We have the box office of the movie, the budget, Oscar nominations, person of color lead, whether or not the movie was an action or superhero movie, drama, horror, or sci-fi, and whether the movie has a female lead. We're going to try to predict box office based upon these predictor variables. Typically, when we want to explore the relationship between multiple variables, we would create the scatter plot matrix. Unfortunately, this is not easy to do in Excel. So what I oftentimes see students do is highlight the columns of all their data, go up to Insert, just select Scatter Plot. This is not the right thing to do. What is happening here is that your vertical scale is representing the units for all of your different variables, which are all meaning different things. Therefore, this is really impossible to interpret. The only variable that it looks okay for is the budget variable, and that's because it has really big values. Otherwise, you can't see any of the things happening with our other variables. So this is a caution not to do this, because this is not what we want to explore our data. A better way that we can explore the relationships between these variables is through a correlation matrix. To create a correlation matrix, we have to enable the Data Analysis Tool Pack. That will be then under Data once it's enabled. You'll see Data Analysis. Under Data Analysis, select Correlation, then press OK. Here we'll put in the box office first and then all of our other variables. Then we have the labels in the first row because they're the names of our columns, so we want to make sure we select that. That's important because then in our output, we'll be able to see which variables are correlated with one another. Here, I'm going to put this into a new worksheet, but I'm actually going to call this correlation matrix. That way I can easily reference it in the different tabs in my Excel workbook. Press OK. Now I have my correlation matrix, and I can look down the columns to see the correlations between box office, budget, Oscar nominations, and so on. Here, I can create a better visualization by creating a heat map. So I can remove all these ones. And the reason why I do that is so that it doesn't mess up the scale when I inevitably do a conditional formatting of these values. I'm going to highlight this data, and to create a heat map, I'll go up to Home and then select Conditional Formatting. This will allow me to really easily see the correlations that are not very strong and the ones that are. So under Color Scales, can select some color scales that I like. You can do green and red, or you can do blue and white and red. I'm going to go with the blue, white, and red. The stronger the color, the stronger the correlation. Here I can see that box office and budget have a correlation of 0.96 or so. Oscar nominations is still pretty weak at 0.04, and then person of color, action or superhero, and drama are all moderately correlated. Horror and sci-fi, I believe what that is, horror and sci-fi are both, and female leads are not strongly correlated. One reason the correlation matrix is also helpful is we can see the correlations between our explanatory variables. So here we can see action or superhero and budget pretty correlated, but they're not over the threshold of 0.90, so we don't need to be stressed about multicollinearity if we add both of these variables into our model. Based upon my exploratory tool, I'm going to select budget, person of color, action or superhero, and drama to be in my model. Coming back to the original data, I'm going to start to manipulate this. So if you're worried about screwing up the original data, I would just copy these values and paste them into a new workbook. This way you have a worksheet for your data. I'm going to call this working data. The way that regression works in Excel is that you need to have all of your explanatory variables next to each other in columns. So because I'm not going to use Oscar nominations, I need to get it out of this position in my columns. So I'm going to delete it and remove it from the data. I can always go back and get it from the original data, but I'm going to delete it from there. And then I'm also going to delete horror or sci-fi and female. I'm going to delete these ones as well. Now I have my 4 variables that I want to use based upon my correlation matrix in a regression model. To perform the regression, I go up to Data and then Data Analysis for the tool pack. I scroll down and select Regression, then I press OK. The first thing I need to input are all the Y values. So I'm going to highlight box office, and I need to highlight all of the data. I can't highlight the columns. I must highlight the data specifically. Then for my X range, I'm going to highlight my column names first and then scroll down to all the columns. I do have labels in my data, and this is important to select this so we can read the output easily. I also have a confidence level. I want to use the default of 95%, so I can just keep this as is. I'm going to put this in a worksheet called Model 1. That way I can reference back to it. And I want it to calculate the residuals for me, but I don't want any of the other things. The residual plots in multiple linear regression in Excel actually aren't helpful in looking at the entire model, so do not select this. Then press OK. Here we have our table of coefficients. The first thing I notice is that my columns are all kind of bunched up. So I'm going to highlight them and pull them out a little bit so I can see my data a little bit clearer. I also notice that all of my values have a lot of digits. So I'm going to reduce these so I can do a better job of just visualizing what I have. Now I'm going to highlight the p-value column here so we can easily see the p-values for the different variables in my data. I can see that budget is a really low p-value, so low that it's just rounding to 0. Person of color, action, or superhero are both significant predictors in the model when the other ones are in the model as well, but drama is not. Drama has a higher p-value, therefore I should drop it from the model. So this is not my final model. So other than just taking a look real quick at the adjusted R-squared, which is up here of 0.927, I'm not going to do much else with this model. Going back to my working data, I'm going to create a new regression model. Now I can remove drama. I'm actually just going to put it over here into the don't use pile, essentially, and rerun the regression analysis. So going up to data, I'll go back to data analysis, select regression, and my Y values are already selected, so I don't need to change that. But my X values, now I need to just select 3 columns rather than 4. Highlighting that new data, I can put my new data model into a worksheet called Model 2. Again, I want the residuals and I want all the other things selected. So now I can press OK. Again, my values are kind of squished together, so I'm going to open this up just a little bit, all the columns making them a little bit bigger. I'm going to highlight my p-values here. And sure enough, I can see all of these now are significant. All the p-values are below 0.05, which tells me that each of these explanatory variables, budget, person of color, action, or superhero, should remain in the model. Again, if I want to reduce the number of digits so this is a little bit easier to view, I can do that up here under Home and round these to the nearest 3 or 2 or 1 decimal places. The final thing I should take a look at is our adjusted R-squared. We can see that this, when rounded, rounds to 0.29. And if we look between our 2 models, we can see that the second model has almost the exact same R-squared as the first model, but we have a simpler model without drama. So model 2 is superior, and I would call this now my final model. I'm going to rename this tab Final Model so that when I look back at this data, it helps me go right to what I need. Now to make sure that my residuals look okay. Here under a residual output, I can create a residual plot by highlighting the predicted values. These will go on the horizontal axis, and then the residuals will go on the vertical axis. So highlighting these 2 values, I'll go back up to Insert and create a scatter plot. Now I have a plot of my residuals. And I can put it up here next to my output. Now I should probably add some axes, so I can add the little plus here, or I can go up and add chart element. Either way, if you're using a Mac or PC, it's a little bit different. But here I can change my titles. This should be predicted. This should be residuals. And under the main title, I can call this something other than residuals. I can call this residual plot for final model. I can also remove grid lines so I can increase the data ink ratio. But looking at this residual plot, I'm going to look for a U shape, a funnel shape, and whether or not there's any imbalance in the data. I don't see any of those violating patterns other than a couple of outliers. This model looks pretty good. In your analysis, you may need to do some more basic model selection. This means that you might have more models to filter through. That's fine. Just continue the same processes of dropping the highest p-value from your model and refitting the data. The final step is to create some nice visualization based upon the variables that remain in your model. Go back to working data. And for working data, I'm going to highlight my 3 variables, and I'm actually going to put this in one more worksheet. Pasting the variables, I'm going to then create a scatter plot between each one of my variables. One of the things that Excel needs in order to create a scatter plot is it needs the X value on the left and the Y value on the right. We can see that this isn't happening with this data now. Just for some housekeeping, I'm going to insert some additional columns between my explanatory variables. Then I'm going to copy and paste box plot to the right of each one of my variables. Then I'll create a scatter plot between budget and box office, going up to insert and creating a scatter plot. This way I can visualize the relationship between these 2 variables. I'm going to do the same thing for person of color and box office. This one is a little bit different because we're dealing with a binary indicator variable. So I can trick R into creating a box plot when I have a quantitative indicator variable and a quantitative response. First, I'll go to scatter plot. Then I'll go back up to insert and select box plot under the statistical charts. Here I can create a side-by-side box plot. Then for the variable, person of color lead. So I'm just going to write in that brief title for just a moment so that I can do the same thing for the action or superhero data. Going back up to scatter, I can go to insert and then create a box plot. It's important that I now add main titles, axes titles, and clean up the grid lines, and maybe perhaps add some color. I can also create a scatter plot where I add a categorical variable to that. You can watch the tutorial on how to do that from the Unit 1 software tutorials. Hopefully this video better helped you understand how you can perform a regression analysis and some basic visualizations of your plots in Excel.